Bismillahirrahmanirrahim. Here we comes an example in the book of Boylestad Electronic Engineering, example 2.26 on Zener Diode. Here comes a problem, problem 2.26. Here you find that for the diode network figure 2.115, determine BL, BR, IZ, PZ. Here I demonstrate a figure you saw and some notes. Here you find that Zener diode is in reverse bias. So in forward bias, Zener diode acts like a ideal diode or general diode. It doesn't change. But in reverse bias, Zener diode is different from ideal diode. In reverse bias, when applied voltage is less than Zener voltage, then the Zener diode is replaced by an open circuit, and when applied voltage is greater than Zener voltage, that Zener diode is replaced by a built-in potential. Remember, here built-in potential voltage is equal to Zener voltage, the output. Here you cannot apply it higher voltage. Here it should be the Zener voltage. Here you find 10 volt. If you find applied voltage 14 volt, you cannot answer here 14 volt. It should be 10 volt. Beyond 10 volt would be cut off here. Now we can solve the problem here. Here you can find then our source voltage is 16 volt. Here our resistance is R, so R equal to 1 kilo ohm. Here our load resistance is 1.2 kilo ohm. So at first we can assume that Zener diode is in off state. Assuming Zener diode is off state, because when we off this Zener diode, assume that off the Zener diode, the voltage should be 0 to VA to 10 volt. Here we can apply a node here, so this voltage is less than 10 volt, so we can depict that this should be a open circuit, and that is in off state. So by applying voltage divider law, voltage divider rule, in 1.2 kilo ohm load resistance, we can say that VA equal 1.2 into 16 divided by 1.2 plus 1 kilo ohm. This is the voltage divider rule. So we can find there 19.2 divided by 2.2. So our output VA is 8.727 volt. So here you can find our total voltage is 16 volt. So here our VR should be 16 minus VA. So 16 minus 8.727, so we can find 7.27 volt here. Here you can find a VL, VR. So this VA is parallel to or indicating that BL is applied to through the RL. So VL equal to VA equal to 8.727 volt. And here you find that our diode is off, Zener diode is off, so our IZ or Zener diode in current should be 0 milliamps. So our PZ or our power dissipation is IZ into VZ. So IZ is, here you can find 0 volt, see 0 milliampere, sorry, 0 milliampere, 0 milliamps into Vz, so 0 milliwatt. So that is our final answer. Iz is 0 milliamps, Pz is 0 milliwatt, Bl is, we can find 8.73 volt, Vr is 7.227 volt. So that is our for problem A. That again you can repeat RL equal 3 kilo ohm in the same basis. I think you understood today's topic. Thank you very much.